Hello again. Tonight we're going to talk about radio emissions from Antarctica. And this is essentially unexpected radio emissions or anomalous radio emissions coming up from Antarctica. So I've probably mentioned in prior presentations that NASA has programs, scientific research programs, whereby they launch helium-filled balloons from U.S. Base in Antarctica near the South Pole. The balloons carry payloads. It can be cameras, infrared, visible, radio, astronomy, all sorts of payloads. But it will loft it up to about 100,000 feet, and it will catch the south circumpolar winds, and it will just orbit the South Pole for about a month, and then they'll command it to release the balloon. A parachute will open, it comes back down, and they recover it, refurbish it. They have to update it or recharge any batteries or whatever. They'll do that, and then they'll find a window where they have a balloon available, and they'll fly it again. If you have enough of these science missions, you may not get to fly every season. And remember, it gets really cold and wintry down in the Antarctic, so they can really only launch the balloons during the warmer months, when the hurricane-force snowstorms don't exist. If you have a mission like the ANITA program, where they were looking to observe Tau neutrinos, then you might only get to fly once, maybe twice a year, or once every couple of years. So you can't do continuous monitoring with any particular instrument. The instrument you see on the right is a radio telescope array. The black things are all solar panels to power it. The white things are the horn antennas, and they go all the way around the outside. They don't face upward and they don't face downward. They face to the side because they're expecting the Tau neutrinos to basically come in from the sides, reflected at angle off of the brackish ice. Not the cold, clear ice, but the ice that sort of splashed in from the outside and from fog coming up off the Antarctic Sea that they can use as a reflector to basically bounce radio signals from Tau neutrinos. Yeah, eventually after a few flights, they did find Tau neutrinos, but they found these other anomalous radio emissions. The ANITA radio receiver, their radio astronomy receiver, receives from 200 megahertz to 1200 megahertz or 1.2 gigahertz. That's the range of frequencies it can receive. The Tau neutrinos are up towards the top end of there. But they found this other signal that they didn't know where it was coming from. It was coming from straight down, not from outer space and not from things on the side. It was coming straight up from the Antarctic. No explanation for it. They've observed it multiple times, logged it, had peer review of it. No, it's coming up from the ground. And where is it coming from? They don't really know. And they don't know what event causes it and what the source of it is. So they do know what it's not. It's not a Tau neutrino because the energy signature is different. And Tau neutrinos would have reflected off the ice, the salty ice. And these are coming from straight below. It's not coming from above the balloon. It's not radio interference like radio noise coming in from the sides. It's not odd instrument noise like special defects in the instruments. They've recorded it multiple times and they've had peer review of it. But it's not sourced from interstellar events. They did talk with the folks also down in the Antarctic at ICECube, which is a neutrino detector buried in the ice. And of the two prominent observations that they have, one was kind of related about the same time frame as a supernova in M82 from 2016. The other one, they could find no other neutrino source to match it up with. So I said, well, why don't you guys look in other forms of observation? Well, there's nothing visual, so the source is unknown and the event that sourced it is unknown. I said, well, what about correlating it with LIGO and VIRGO and KAGRA, the gravitational wave interferometry observatories? Apparently they haven't done that. The balloons aren't there all year long, so they don't know how long the signal lasts, if it comes and goes, and what the occurrence rate is. So they have more research to do. But what we do know about them is we have the energy range for them. This is the picture at the right is a combination of essentially historical observations plus computer simulations. You can see up in the right where it says background simulation, signal simulation. Those are computer simulations based upon observations. The square data points are the actual observations that they've made. Now, unfortunately, they're just counting numbers of events. They're binning the events so they can see how many occurred. And then they're saying what level of energy they have so they can discriminate and say, well, we only want the ones above this level. So they're doing the analysis of the values and they're finding out, yeah, it's there. Yeah, they're measuring it. It seems to be something that they don't know anything about. They're just referred to as anomalous radio emissions. They're coming up from below. They're coming up from the Antarctic. Since they don't always see them, but they're not always up there observing, they're just believing them to be intermittent. In other words, not continuous. And the balloon's not up there all year long. And sometimes they swap out instruments, so they don't always have the radio antennas. And by not flying all the time, they can't tell that these things might be seasonal. Because remember, they only fly the balloons in the Antarctic summertime when they don't have all the storms. So I said, well, here's a thought. Since I'm one of those people that understand piezoelectric effects, the picture on the right is if you removed all the ice from the Antarctic continent, what you have left is essentially mountains, very hard rock, granite type mountains. And then it's covered with miles of ice. It's a known fact that if you take granite, which has quartz in it, and you apply compression to it, you're going to get an electrical output. Well, if you did that with, miles thick worth of ice, and you were compressing a granite mountain buried miles beneath the ice, you may get a piezoelectric effect. And if the material that the electricity interacts with is kind of semiconductor-like, like seawater mixed with other minerals, you may get a emission in the radio band, because the electricity wants to do something. And if it finds other chemical compounds, it can actually produce RF signatures. If it's a large enough area, which the Antarctic is a large enough area, and if the effect is over a large enough area, miles of ice sitting on top of giant mountains made out of granite, then you can get a large radio field from it. And it might be going straight up out of the mountains into the sky and being picked up by your balloon that's circling over the South Pole. But you need more information. You need to know, well, is it only during certain seasons? Because the ice buildup changes throughout the year. And is it only during certain seasons you're getting this effect? Is it, you can see there's sections of the mountain. Down towards the bottom, there's a curved area. And then up towards the top, there's higher peaks. Are there radio signals coming out from different places? So when you do your pirouette around the South Pole, are you picking up the signals in different places, different amplitudes? But in order to do more research, you have to continue to have the balloons flying, which means we need the balloons funded. Here's something that I just connected the dots. We'll find out if it actually makes sense or not. We've reduced the amount of chlorofluorocarbons, or CFCs, freon kind of thing that we use in air conditioners and hairspray and things like that. For a while, the Antarctic ozone hole started to shrink. Now it's starting to grow and it's seasonal. In other words, it's bigger than it used to be, but only during certain times of the year. And then it shrinks down a little bit during the winter months, and then it grows back again during the summertime. And I thought, well, if there's a large flux, a large volume of radio photons coming out from the surface of the Antarctic, and they're going up to high altitude, then are they having an effect? Are they pushing on the ozone? Because ozone is a form of oxygen, and it has a charge. And if the radio energy coming up has a charge that's the same, then the phase of that radio signal is actually going to be pushing on the ozone layer. Another thing is just the radiation reflection energy. The radiation pressure could be pushing out the ozone gas. But until we do further research, speculation. So we have a quandary. The NASA ANITA program found some anomalous radio signals. They were coming up from the Antarctic. Signal source is unknown. The event is unknown. We know they're not Tau neutrinos, but we're going to have to launch additional balloons with additional radio telescopes to help us find out what's going on here. Trouble is, if you read the NASA 2026 budget, the line item, the high-level line item for balloon scientific research over the Antarctic has been zeroed out. That not only means no radio astronomy, that means no optical astronomy, visible, infrared, any of that. If it's balloon launch from the Antarctic, you get no funding for that. The best way to have something remain a quandary, an enigma, is don't fund the research necessary to find out what's going on. I'm sure that they zeroed it out because somebody said, what's that all about? We don't need that. We need to save money. We need to reduce the budget, reduce the deficit or whatever. So I can understand that. That means that we'll have a mystery that remains a mystery because we're unwilling to spend that amount of money on it. It's not billions per year. It may only be tens of millions per year, and we do share it between different types of instruments, the balloon rides. That also means a reduction in jobs, a reduction in outsourcing for people to build these instruments, a reduction in the logistics of moving them from wherever they're built down to the Antarctic, and the travel expenses for people that go down there and operate these things. Compared to a rocket launch, a balloon observation is cheap. So the savings might be plausible. If we're saving it and we're not giving it away to people, then okay. But if we're saving it in order to give away more people more money when they're not at the bottom of the food chain, so to speak, then maybe that's not the reason for cutting it. But maybe we're just ignoring the signal source behind the curtain. And of course, as usual, links. Where this all started for me was I was watching Anton Petrov's weekly video, and he did one on this. And yeah, that sparked my interest. And then I started looking at other YouTube videos from other sources. And then I started looking at the research papers. Pennsylvania State University had a good research article on it, as well as they went looking in other radio astronomy observatories that were, doing work in the Antarctic, and they were looking for these observations, and they couldn't find any ground level observations which would say something from space is coming down to the ground and being picked up by ground-based radio observatories. They were being picked up by the balloon because it's coming up from the ground out into space. And then if you want to know more about the ANITA program and the other thing that they use for detecting neutrinos down in the Antarctic, and then the particular kind of radiation that they were looking for with the balloon is called Askaryan radiation. And then that's got a peer called Cherenkov radiation, which is a similar cosmic ray skyburst generated observation. And then if you're interested in the gravity wave, the LIGO Observatory, and they finally opened up a science center where they consolidate all of the LIGO, VIRGO, and KAGRA gravity wave observations. So if you say, well, I've got this signal that the balloon detected, were there any gravity waves recently? And you can set up a date time range, and then you can go look in the GW Open Science Center and see if was there a gravity wave occurring at the time, and it'll check both the LIGOs, the VIRGO, and the KAGRA. And then if you weren't aware that we still have an ozone problem above the Antarctic, and it's actually getting larger, then there's an article on that. And then the Antarctic ice pack, even though it's seasonal, it grows and shrinks. At the point where it shrinks, it's shrinking more than it has been in prior years. So we're losing a bit of the ice pack. And as you lose it, that's less weight on top of the granite mountains, which would create a variance in the piezoelectric effect. What is piezoelectricity? There's a link to that. What is this radiation pressure that might be pushing on the ozone? There's a link to that. Okay. Comments, questions? Was it too much in too short a period of time?
It was a lot.
Yeah. I'm trying this new motif to see if it increases our popularity on the internet, on YouTube. So this will be our second attempt at doing something in the 30-minute range. But I still have to edit it.
Were there things that you would have liked to give more definition to?
Yeah, I would like to have gotten more detail, got at least one more slide in that said what frequency these anomalous emissions are. I think they're around the gigahertz range, but I couldn't find specifically what they are. And as a amateur radio astronomer, it's just a curiosity. And I'm like, okay, these anomalous emissions, what's their, what's the wavelength? What's the frequency? Because then I might be able to correlate that to quartz crystals in granite rock and how much pressure it would take to do that and what the flux would be. And that would take me down a deep rabbit hole and might be a few slides worth. But now you're talking about something instead of being 30 minutes, to be more like an hour. And as I showed earlier, A 30-minute presentation gets lots of views. An hour-long presentation gets fewer views.
Thank you.
Any comments or questions before I stop recording? Hearing nothing.